In fact, NASA is supposed to release high-resolution images of this object when it gets very close to Mars on October 3rd. First, NASA has broken their silence. They will release images of 3I Atlas on Wednesday via live stream. So they put up the live stream page. It will start at 12 p.m. Pacific time on November 19th. And based on what you're describing, this could soon be the biggest story in the world. Literally the biggest story in the universe. And so SETI's sudden X post caught everyone by surprise. They informed their followers that NASA would be sharing new spacecraft and telescope images of 3I Atlas on November 19. Images collected not from a single observatory, but from multiple spacecraft and powerful telescopes across the solar system. NASA rarely holds a single event for a comet, and SETI rarely highlights one unless the data is truly compelling. The timing alone sent shockwaves through the astronomy community. Why now? And why this object? Stay tuned, because what happens next will blow your mind. If you are fascinated by the mystery of 3I Atlas and want to see more amazing cosmic stories, hit that like button and let the universe know you are watching. Every click helps keep the quest for the unknown alive. Comment below and let me know where you are watching this video from. I want to see what corners of the world are witnessing this along with me. At the same time, a new series of images of 3I Atlas began circulating, quickly attracting the attention of scientists and the observational community. The sharp, high-contrast frames revealed a bright cloud with a distinct structure and unusual color patterns, creating a form far different from any natural comet ever recorded. 3I Atlas appeared larger and more vivid than the surrounding stars. And most notably, its shape changed subtly from frame to frame. The tail appeared asymmetrical, almost unstable, suggesting that some spiraling or shifting motion was taking place within the dust cloud. Even without knowing the origin of the images, the abnormality in the object's behavior was clear. The attention grew when Avi Loeb published even more stunning images in a Medium post: multi-directional jets, firing as if under control, sharp tails, and collimated columns of gas extending into space. These were not simulations or augmented images, but actual observations, showing that 3I Atlas was not only powerful, but also incredibly strange. Each subsequent frame revealed a new layer of structure, making the object look more like a complex system of gas and dust, almost like a working machine than a vaporized block of ice. The combination of the enhanced SETI signal, the impending NASA announcement, and the increasingly inexplicable images has created a wave of intense speculation. 3I Atlas is challenging every conventional model of comets, from their morphology to their dynamics to their physical properties. And with each new piece of data, the question becomes more pressing. What is really going on out there in interstellar space? While NASA and other government agencies continue to remain silent on any questions about 3I Atlas's unusual behavior, that information gap has been quickly filled by another source: a community of independent astronomers across the United States. Unencumbered by approval cycles or lengthy publication processes, they observe the comet live, continuously, and without any withholding of results. Their stream of images, posted as they are received, without editing or delay, has become the most up-to-date and detailed source of data about 3I Atlas as it changes nightly across the sky. These images reveal structures that, if only official data were available, the public might have to wait weeks or months to see. And among these observations, one set of images in particular has caught the attention of experts and speculators alike. A sequence of frames that suggests 3I Atlas may be spinning unusually fast, seemingly changing direction in a matter of minutes. The phenomenon immediately became the focus of scientific forums in the US. Some researchers explain that the unusual rotation speed could be due to asymmetric jets from the comet's outgassing. However, many independent analysts pointed out that the change in direction was too fast and too neat, more like a controlled reaction than a random eruption of ice and dust. This quickly fueled conspiracy theories, especially in an American public sensitive to anything related to government transparency. Some reputable media outlets began to ask, if a network of amateur astronomers could record this strange behavior, NASA, with equipment hundreds of times more powerful, must have known about it long ago. So why did they remain silent? Some commentators on social media have gone further, suggesting that NASA's silence is not a lack of data, but rather a direction from above, especially given the recent closed-door meetings between Congress and the space agency that have never been publicly explained. Some U.S. media experts have suggested that the combination of independent observations, unusual signs of the comet, and NASA's delay is creating a whirlwind of information that has the same appeal as the announcement of Oumuamua in 2017, but this time with a much greater level of tension and doubt. While serious scientists remain cautious in their assessment, the series of images showing 3I Atlas's incredibly rapid rotation has planted another question in the minds of the American public. Is this still just a natural comet, or is something actually correcting its course in space? While NASA continues to remain silent, the independent observational community is emerging as the most reliable source of information, a situation unprecedented in the history of American astronomical research. The observer behind these remarkable images later explained in detail how he captured them. And what is astonishing is that the entire setup consisted of just a standard telescope and an RGB camera without any filters. He removed the standard IR, UV filter to preserve the subtleties of color in the dust clouds, trying to reproduce the 3I Atlas as faithfully as possible. Dozens of long exposure frames were stacked to reduce noise, and just enough sharpening was applied to highlight the structure without creating artifacts, a careful approach usually only seen in specialized labs. What's truly shocking is the sequence of images taken just minutes apart. 3I Atlas isn't static like a drifting comet. Its outline is constantly shifting, as if stretching and twisting slightly, while dust streams bend and flare in new directions, suggesting complex dynamics. Brightness sloshes through the comet's surrounding cloud in patterns too regular to be random. From this observer's perspective, the conclusion is clear. 3I Atlas is rotating, probably counterclockwise and very fast. The speed at which the shape changed in just a few minutes has fueled a series of conspiracy theories among American astronomers. Many have questioned whether the unusual motion is the result of natural jets or the traces of an unknown control mechanism. Some forums have even discussed the possibility that 3I Atlas is self-correcting, a behavior not seen in natural comets. Despite the traditional experts' reservations, this series of images provides what NASA has been avoiding: visual evidence that 3I Atlas is operating in an organized and almost proactive manner. Given the U.S. Space Agency's continued silence, it is these independent and unassuming observations that are raising questions the scientific community cannot ignore. The ability of 3I Atlas to spin fast enough to change shape in minutes has profound scientific implications that are hard to ignore. Cometary nuclei typically take hours, even tens of hours, to complete a rotation. Even the fastest spinning nuclei ever recorded rarely undergo visible morphological changes in the space of a minute or two. If 3I Atlas is indeed spinning that fast, it means its jets may be sweeping through space like rotating jets, creating thin, sharply oriented, and rapidly changing dust tails, just as they appear in many recent images. This unusually rapid rotation also opens up more complicated physical scenarios. Centrifugal force could create high internal pressures, causing the outgassing rate to fluctuate wildly, even increasing the risk of fragmentation of the comet's nucleus. Rather than being a sign of chaos, 3I Atlas's constant visual changes, from changing colors to constantly shifting tails to asymmetrical jets, could be entirely predictable consequences of an object spinning under the intense heat of the sunday. The independent observer who recorded the sequences acknowledged the limitations of his equipment and understood the risks of overinterpreting amateur data. However, the remarkable consistency of the frames, taken just minutes apart, made his conclusions difficult to dismiss. Given what he had seen, many American astronomers began to question whether 3I Atlas was simply a fast-spinning comet or an object behaving according to principles that science had yet to grasp. These independent observations were not alone. Around the same time, Avi Loeb published a short but powerful article in which he compiled the clearest and most detailed images of 3I Atlas available to the public. Loeb did not offer hasty theories or bold speculations, instead letting the images tell the story. And just looking at them, anyone could see that this comet was completely different from the diffuse, soft-edged images usually associated with such objects. Instead of a hazy mass of gas, 3I Atlas appears as a complex structure of light with jets emanating from different regions of the surface. They branch in multiple directions, forming intersections and forks, as if they were an orderly, dynamic framework within the comet. Most striking of all is the bold reverse tail, which cuts across the frame and points directly toward the sun, a feature so rare that it almost defies all familiar comet models. Meanwhile, 3I Atlas's main tail extends into a narrow, collimated column of gas, much more coherent and concentrated than the wide, scattered tails of natural comets. These images don't just appear and then disappear. Over multiple exposures, several days apart, the same series of strange features recur with remarkable consistency, suggesting that 3I Atlas either maintains its structure in harsh environments or rapidly rebuilds itself after each disturbance. This has made observers even more curious about the object's true nature. For an American public accustomed to fuzzy textbook illustrations of comets, Loeb's images were a direct assault on intuition. Not only were they stunningly beautiful, but they also posed questions that challenged conventional wisdom. Was this simply a violent comet, or a sophisticated structure operating on a mechanism unknown to science? And, more importantly, were these orderly features the result of nature, or the traces of something far beyond our current understanding? What makes Loeb's images stand out the most is the sense of purposefulness that 3I Atlas seems to convey. The jets that come from the comet don't look chaotic or random like typical outgassing. They look organized, as if they're coming from distinct vents or defined areas of the surface, rather than from a uniform outgassing plane. Some jets fan out like fan blades, others are sharp as spears, and all combine to form a network of bright filaments that crisscross the comet's dust cloud, suggesting a sophisticated structure at work beneath the surface. Even without detailed analysis, the images convey a clear message. There is a powerful internal activity going on inside 3I Atlas, a system of thrusts, twists, counterforces, and interactions spinning around a nucleus that is changing at an astonishing rate. Loeb's decision to let the images speak for themselves rather than impose a single conclusion only adds to their appeal. The viewer gets the sense that 3I Atlas is not just bright, but performing, not just active, but structured, not just a comet, but possibly something that requires a more sophisticated scientific model than any currently used to describe comets in the solar system. With NASA remaining silent and American public skepticism growing, this series of provocative images has made the 3I Atlas story harder than ever to ignore. Is this just a comet behaving unusually, or is it a structure operating on a mechanism that modern science has only scratched the surface of? Each photo Loeb chooses to post seems to push that question one step further. SETI's focus on NASA's impending announcement now stands in stark contrast to its silence on independent findings from the observing community. SETI did not comment on the spin rate, the jet streams, or any other unusual phenomena seen with amateur telescopes. The organization is typically cautious, rarely speculating publicly, and never exaggerating unverified data. But NASA's choice to broadcast the announcement live to its millions of followers was an important scientific endorsement, an indirect acknowledgement that 3I Atlas was a special object worth paying attention to. Visitors from interstellar space are extremely rare, and every flash of light, every small change they leave behind is of great scientific value, whether normal or completely unexpected. So the fact that SETI took it upon themselves to promote the NASA event suggests that they believe what they are about to announce is not routine data. Even without mentioning the strange behavior being observed from the ground, the fact that SETI actively directed the public to NASA's announcement underscores its importance, as if it were a subtle warning that the images and analysis that are about to emerge could change how we understand 3I Atlas. In an atmosphere where independent observations continue to reveal inexplicable things, SETI's silence has not lessened skepticism. On the contrary, it has only increased the American public's belief that what NASA is about to release is not simply a set of comet images, but may be an important piece in a much larger story slowly emerging from interstellar space. That anticipation now focuses on NASA's November 19 event, an event that becomes more significant with each new amateur observation. NASA has confirmed that multiple missions have recorded 3I Atlas, meaning the comet's behavior has been observed from multiple wavelengths, multiple types of instruments, and multiple angles. It's no longer just a random snapshot from lucky observers, but a comprehensive set of data from space. If the unusual rotation rates are real, NASA data is the only place where we can definitively confirm them. If the jet streams are sweeping in arcs, spacecraft cameras should be able to capture their motion and structure with a precision that ground instruments can achieve. If 3I Atlas's strange jet tail is caused by a combination of rapid rotation and solar wind, multi-mission analysis from the missions should help clarify the physics behind it. What we have now are observations limited by atmosphere, weather, and viewing angle. Orbital data will eliminate all of those confounding factors. For now, the world only sees 3I Atlas through chance glimpses captured by a few observers at the right time and in the right direction. But that will soon change. Soon, we will have a view from space that is sharper, deeper, and far less hazy. And when NASA releases the official data, the question will no longer be whether 3I Atlas is unusual, but how much it will challenge current scientific understanding. Speculation about the nature of 3I Atlas, at least for now, revolves around possibilities that are entirely within the realm of science. One of the most plausible hypotheses is that its rapid spin is caused by asymmetric outflows, which act like natural thrusters, accelerating or changing the direction of the comet's nucleus. Another possibility is that 3I Atlas is tumbling, causing unpredictable rotations as sunlight heats uneven areas of its surface. As with interstellar objects, a mix of ice, dust, or compounds with unusual mechanical strength could make their behavior different from the traditional comets that scientists are familiar with in the solar system. None of these explanations require us to resort to an extraordinary scenario. They simply require a more open-minded view that 3I Atlas may not follow the familiar patterns of comets in the solar system. It comes from a different formation environment, influenced by different stars, different pressures, and a different cosmic history, conditions that could produce behavior we've never observed before. But that very difference is what makes 3I Atlas so fascinating. An interstellar object whose every feature, while still explainable by science, is nuanced enough to make one wonder if there's something else going on beyond our understanding. Still, the visual evidence is undeniably strange. Multiple jets shooting off in different directions, as if triggered by separate mechanisms. A sharp, steady tail that defies solar pressure in a way that is hard to explain by conventional outgassing models. And a long, narrow, collimated plume that shoots into space with astonishing stability. All of this combines to create the image of an object that is dynamic, complex, and constantly evolving. These data don't prove anything beyond nature, but they suggest a level of sophistication that makes any serious scientist admit that we need better data to understand what's really going on. It is here that NASA, SETI, and researchers like Avi Loeb form a particularly interesting scientific triangle. NASA takes a cautious stance, waiting for the spacecraft data to speak for themselves rather than jumping to conclusions. Avi Loeb chooses to highlight unusual details and urges the scientific community not to dismiss them simply because they don't fit a familiar pattern. SETI maintains a controlled interest, avoiding speculation but actively guiding the public toward closer observation rather than emotional interpretation. These three different approaches, combined, have shaped 3I Atlas, not as a mysterious object, but as a rare opportunity, a chance to test current physical models, to gain a deeper understanding of interstellar objects, and to observe a phenomenon that has rarely been witnessed in cosmic history. As the world watches the hours leading up to November 19, nightly observations by independent astronomers continue. Each new image adds another piece to the emerging puzzle. 3I Atlas is not behaving like a quiet interstellar visitor that passes the sun and then fades away. Instead, it is displaying a level of intense and unpredictable activity, constantly changing shape, and may be rotating at a rate far beyond what current models predict. The big question now is not whether 3I Atlas is unusual, but what those unusual things mean. Is the rapid rotation real? Are the jets working in unison, suggesting a complex internal mechanism? Or is the comet exhibiting dynamics never before seen? All of these hypotheses now depend entirely on the next generation of data. When NASA finally releases its images, they may confirm what independent observers have seen, disprove them, or worse, for those who prefer certainty, reveal entirely new features no one had ever thought of. Until then, the skies remain silent, broken only by the occasional shutter click of cameras, as those patiently watch this interstellar visitor, an object that defies every known understanding we thought was solid.